Electric current. Our objective is to know a current carrying wire has a net electric charge of 0. Electric current is the flow of electric charge. In solid conductors, electrons carry the charge through the circuit because they're free to move throughout the atomic network. These electrons are called conduction electrons. Protons are bound inside the atomic nucleon, locked in fixed positions. Inside of an atom, you have the nucleus, right? And the protons are stuck with other protons and with other neutrons. So you can't have protons flowing, because if that were to happen, that would mean the protons were pulled apart from the neutrons and the other protons. Meanwhile, the electrons float in this outer shell called the valence shell, and because of that, they're free to move. So we look at the flow of the electrons as they're moving throughout the circuit. In fluids, like the electrolyte in a car battery, battery acid you've heard about, positive and negative ions, as well as electrons, may flow. Electric current is measured in amperes with the symbol capital A. So that's the unit of measurement, amperes. We usually talk about amperes in the short version, so we just call it an amp. And an amp is the flow of 1 coulomb of charge per second. So if we look at this cross-sectional area of the wire, if we chop the wire in half and we look at just the round part, an amp is the flow of charges per second. So 1 amp is 1 coulomb per second. 2 amps is 2 coulombs per second. When the flow of charge past any cross-section is 1 coulomb, and 1 coulomb equals 6.24 billion electrons per second, the current is 1 ampere. That's a huge number. A whole bunch of electrons flowing through this section of the wire. While the current is flowing, negative electrons swarm through the atomic network of positively charged nuclei. So these electrons are jumping from positively charged atom to positively charged atom. That's what conductors are. It's just a collection of positively charged atoms. Under ordinary conditions, the number of electrons in the wire is equal to the number of positive protons in the atomic nuclei. The electrons flow. As electrons flow, the number entering is the same as the number leaving. Just like that pipe filled with water. We put a little bit of water up here, eventually a little bit of water in up here, eventually down here, the water is going to come out. Same amount, no more, no less. As electrons flow, the number entering is the same as the number leaving, so the net charge is normally 0 at every moment. Concept check! You should now be able to answer this question. What is the net flow of electric charge in a current carrying wire? At this time, go ahead and move on to your practice.